Okay, so hello again. Okay, so let me just check if you guys are already in front of your computer. So again, just give me thumbs up. Okay, very good. So you guys can start eating now since it's already lunchtime. So same rule. So as long as we cannot see you eating and then we cannot hear you eating, then it's okay. Okay. So after transforming this one, so as you guys can see, we can now transform this one into a series connection. So how? Of course, by source transformation again. So from current into a voltage source. So in here, it will become something like this. So imamano-mano na lang natin since I think kayang-kaya nyo namang i-analyze ng hands-on, okay, or via your mind only. So current source to voltage source, so they must be in parallel, and then after that they will become in series. So V is equal to I times R. So I is equal to 3 ohms and then R is equal to 1 ohm. So 3 times 1 is 3 volts, and then naging series na sila. Okay, so the same with this one. So V is equal to I times R. So 3 times 2 is equal to 6 volts, and then they are now in series connection. And then wherever is your arrow pointing, that is your positive uh, symbol. Okay, so we have the positive right here and then positive right here. So yeah, that's it for the first transformation. So were you guys able to get that one?
Yes, sir.
Okay, very good. So as you guys can see, we have now here a triangle source. So this is actually the symbol, okay, of a dependent source. So if it's independent, it is a circle. But if it's dependent, okay, it is a triangle. And then mostly, if it's a voltage dependent source, okay, it comes with this letter I right here. And then vice versa, if this is a dependent current source, it has a voltage variable right here. So meaning it depends on the current that is flowing in here. Okay, so the voltage or the final voltage that will flow in here is being dictated by the current that will flow in here. So we have a larger current, then we have a larger voltage source right here. But if we have a lower, then of course a lower voltage source right here. Okay, so that's why it's called dependent source. Okay, and then another thing is we can now again arrange this one into something like this. Okay, so 3 volts and 1 ohm goes up right here, and then 6 volts and then 2 ohms. Actually, nandito pala, na-combine na pala to. So ito muna, let's combine these two first. So 2 ohms and then 3 ohms. So since they are in series, it resulted into 5 ohms. Okay. And then this voltage source also goes down on this branch right here. So ito na siya. So the same with this one. So 1 ohm and then 2 ohm is in series connection. So just simply add those two. So it became 3 ohms now. And then this 3 volts right here goes up on this branch right here. Okay. And then the middle one stay the same as it is. So this is one thing that we should not touch. Okay. Since this is the one that we need to solve. Okay. The current that is flowing on this branch right here. Okay. So did you guys get this one on how did we arrive with this letter B figure?
Agad naman po, sir.
Okay, great. So just let me know if there is a part that you were confused or you wasn't able to follow. Okay, anyway, napaka-straightforward naman lahat ng mga circuits dito, so I think hindi kayo mawawala. Alright, so after that, okay, you can now transform this one, and this one into a another source. So from voltage sources into a current source. Okay. So why are we doing that one? Because if we have a current source, we can just simply add them as long as they are in, as long as we know their direction. So the same direction will be added, and then opposing direction will be deducted. Okay. So again, we also have the same rule. Whichever is the higher current, that's your first operand, and then whichever is lower, that will be your second operand. So there is no way that we're going to have a negative flow of current in source transformation. So it is always the higher current minus the lower current. Okay, so for the case number one, we have this computation right here. So I is equal to V divided by R. So V, ay, okay, Bright. So V is equal to 3, and then R is 3 ohms. So 3 divided by 3 is 1 ohm, okay, which resulted into this uh, current right here. Okay, so the same with this one. So V divided by R, which is 1 divided by this R, which is resulted into something like this, which is same with the case number 3. So V divided by R, which resulted into this formation right here, or this circuit right here. So I hope it's clear. So from series, of course, it became parallel connection. And then wherever is your positive sign, so of course, ganun din. So that is your arrow will be pointing, okay, for the current source. Okay, so I'll give you guys 10 seconds, 10 to 20 seconds to analyze on how did we come up from this circuit into this circuit. So, how was it? Were you guys able to get this one?
Yes, sir. I get this po.
Okay. So just in case you wasn't able to get it, so the explanation is on this left side right here. So after this, of course, we can now add those currents. So from here, we can add this one and this one. So 6 over 5, okay. Ang ginawa niya muna pala is yung opposing. Well, anyway, so let's put this one aside for now, the addition. So what he did first, okay, according from my presentation right here. So inuna niya to, okay, this 1 amp right here, and then 6 over 5 amps right here. So again, whichever is a higher, that is your first operand. So since 6 over 5 is higher, so that is why we have 6 over 5 right here first, followed by the opposing current, which is 1 ampere. So 6 over 5 minus 1 is 1/5 ampere. Okay. And then for this one, you can now combine them as 1. Okay, so yung result neto na 1/5 will be added with this 1i sub 1 right here. So 1/5 plus 1i sub 1 is equal to 1 plus 5i sub 1 divided by 5. Okay, so just simply apply algebra, basic algebra, and then you will arrive with this kind of equation. Okay, or you can just simply eliminate the denominator by multiplying 5 on the entire equation, and then you will get this one. Okay, so after that, uh, he did next is we can now combine, okay, those two resistor. So take note that we must not, okay, we must not touch this 5 ohms or this branch right here, which has an I sub 1, because this is the one that we are trying to solve. Okay, the current that is flowing on this particular branch. So the only thing that we can do is we can add this 5 ohms and then 3 ohms via the rule of parallel connection. Okay, so 5 times 3 divided by 5 plus 3 will give you 15 over 8 ohms. Okay, and then after that, you can now have this as your final, not really final, okay, a semi-final circuit. Okay, so we're almost near to this kind of circuit. So again, our goal is to have a series connection. So we have here the resistance, and then the current, and then the resistance, which is this one. So again, I'll give you guys 20 to 30 seconds to analyze this one. So if you don't have your calculator with you, you can just know the concept on how did we arrive with this 15 divided by 8, and then just verify these values later on. Okay. Well, I think madali lang, 5 times 3 is 15, and then 5 plus 3 is 8. So, ayun, nandun na rin pala. Okay, so how was it?
Sir, na-gets naman po. Very clear naman po yung nakalagay, sir.
And then very,
Very clear, sir.
very clear. Okay. So yeah, kaya hindi ko na pinapakita. Very detailed kasi. Okay. So thanks to the reference where I got this one from. So I think this one came from All About Circuits. So mostly naman lahat galing sa All About Circuits. So it is one good website that I found when it comes to electrical circuits. So what about Mr. Francis and Mr. Michael and then Miss Grace?
Gets naman, sir.
Na-gets naman po, sir.
Okay, very good.
Gets, sir.
So after this, so nakikita nyo na siguro kung paano ulit yung mangyari. So from current source into a voltage source. Okay? But before we can do that one, okay, so we have to parang simplify, okay, this equation right here. So, V is equal to I times R. So, ganun pa rin naman siya, I times R pa rin. Okay, however, so, hindi na siya kaagad-agad yung parang voltage na makukuha natin. Okay, so it comes with this letter I right here. Okay, so it needs a further simplification wherein we're going to need a it's either KVL or just simply Ohm's law. Pero I think mas so dito kasi parang mas okay na yung KVL. Okay? Since even though we know the voltage and then we know the total resistance, we won't be able to solve the voltage of this one, okay? Or the current of this one since we have a dependent variable right here. So in order for us to eliminate this one, we're going to use KVL so that we can combine those I1 and then we have another negative 5 I1 right here. Okay, so we can just combine them as one, okay, as one current, and then we'll arrive with a single current right here. Okay, so ganun lang naman siya. After transforming this one, you will have a 3 plus 15 I1, okay, divided by 8, which is now this one right here. So from parallel, it became a series connection now. Okay, and then from here, just apply KVL. So just simply follow the polarity of this one. So ito kasi yung kinukuha niya is yung inner. Okay, or ano bang inassume na okay. So hindi kasi ako sanay. So ang ginawa niya dito, okay. So ang ginamit niya is the other way around. So it's the current method. Okay. So kung ako kasi laging oops, kung ako laging clockwise, lagi akong pa-clockwise, and then whatever is the sign right here, that is the one that I always get. So since we have a negative right here, we have negative, my bad, positive, negative, and then positive. Okay, para maging contradicting. Kasi magiging voltage drop dapat dito. So that's the only common sense or the common symbol for this resistance right here. So the same with this one. So we have negative and then positive. Okay, so just follow that one. It will give us a negative source, okay, which is this one, and then negative ay positive pala, positive 5 ohms, and then positive 15 divided by 8. Okay, so from here they will be added with each other. Or if you want to have the same let's say symbol whatever we have in here, okay, so just multiply this one by negative. So ito magiging positive na, and then ito magiging negative, negative. So negative and then negative. Okay. So yeah, either of those two will be fine. So depende kung ano yung mas preferred nyo, it will give you the same result anyway. So again, if you got a negative current, just make that one positive, and then ayun, just change the assume direction of your current. Okay? Kasi hindi yun yung tama. So in here, the correct flow of current is flow of current, so yan, medyo pixelated na, nilakyan ko, is counterclockwise. Okay? So, mangyari nito is positive, negative, and then positive, negative. So, pag ganun. So, positive yung voltage source, and then negative dito, and then negative ulit. Which is now the same with this one right here. Okay? So, okay, so I think I need to explain this one. All right, so let's try to answer this one since this is our first time, okay, in solving a KVL equation with a dependent source. So what happened right here is, okay, let me remove this one for now. Okay, so from here we have 3 plus 15 I sub 1 divided by 8. That is a positive voltage source. And then we have here negative 15 divided by 8 times I sub 1. Okay, because we only have a single current in here. Minus 5 I sub 1. I sub 1. Ito yung 1. Okay, is equal to 0. And then as you guys can see, we can actually combine these two since they have the same uh, the same unit. So 3 plus 15 I sub 1 divided by 8 minus 15 divided by 8 plus 5 is equal to 55 divided by 8 I sub 1. Okay, and then from here we can separate this 1 into 2 since they have the same denominator. 3 divided by 8 plus 15 I sub 1 divided by 8 minus 55 divided by 8 I sub 1 is equal to 0. And then from here, pwede na natin silang i-add lahat since they have the same denominators. Or just simply multiply everything to 8. Okay, so multiply everything to 8 para lang mapakita. And then everything will be cancelled. Okay, and then we now have here 3 plus 15 I sub 1 minus 55 I sub 1 is equal to 0. And then from here, we can add these two since they have the same unit. So 15 plus 55, mali pala, negative 55. Negative 55 plus 15, since they have different uh, tawag dito, symbol, okay, which is the other one is positive and then the other one is negative. So in here, we have 3 minus 40 I sub 1 is equal to 0. And then this transpose this one on the other side. 3 is equal to 40 I sub 1, and then you can now find the I sub 1. I sub 1 is equal to 40, mali. 3 divided by 40. So I sub 1, ano ba nakalagay dito? Fraction din yata. So let's see. So there you go. We have the same result, which is 3 divided by 40 amps. Okay, so that is now the current that is flowing on this I sub 1 right here. So are we clear so far? Are you guys able to follow my solution, my messy solution?
Yes, sir. That's one.
Yes, sir.
Okay,
Mm.
so yeah, you can use KVL, you can use KCL, so that completely depends on you. But you know, you can just simply use Ohm's law if you want, okay, as long as it's applicable. So okay, as a summary, okay, So we have this kind of series connection, then it can be transformed into this uh, circuit. So from series to parallel, from voltage to current, okay, and then vice versa, of course. From current to voltage, okay, you must have a parallel connection, and then it will go to series connection. And then wherever is your positive sign, okay, that's the arrow that will be, or that the arrow of your current will be pointing. Okay, oops. So the same with this point. It's just that the arrow is pointing downwards. Okay, so the same with dependent sources. So in here, it's just that we have this equation right here, okay, wherein let's say the I is dependent to voltage, or the voltage is dependent to I. So I drop those two. Okay, so they are depending with each other. So from voltage source to current source, and then wherever it's assigned, it is your arrow wherever it's pointing. So the same with this one. So we have a downward, or the positive sign on the below. So we have a downward current right here. Okay. So here are the sample videos. Well, you can also find this one on the watch videos, I guess. And then if you want to have a Tagalog video, so you can also check this one out. Okay. So super recommendable to watch. And then here are the references. Well, of course, this one came from All About Circuits. And then here are the other related articles, just in case that you still need more information when it comes to source transformation. So you can check the Circuit Globe or the People Clarkson. Okay, so yeah, that's how easy to solve a source transformation. So are we clear so far?
Yes, sir.
Yes, sir.
Okay. So if you guys are going to ask me, this is the easiest theorem that I've learned so far. Okay, so sobrang dali niya since it's all about transforming series to parallel and then parallel to series hanggang sa mag-arrive kayo sa series connection. So ganito. Okay, so that's it for the source transformation. Let's now move on to the delta y and y delta transformation. So delta, the symbol of delta is of course this one, okay, and then y is literally y, okay, and then vice versa. So you can transform delta to y and then y to delta. Okay, that's why we have this kind of representation right here. Well, anyway, so just a short background. So the delta Y transformation is an extra technique for transforming certain resistor combination that cannot be handled by the series and parallel equations. So again, there are some circuits that we cannot just easily or convert that one right away into a series connection or a parallel connection. So if that is the case, then we have to use the delta to Y or Y to delta transformation. Okay. So this delta to y, this is also referred to as a pi t transformation. So again, delta and then pi is just the same, just a different terminology. So the same with y. Y is equal to t, okay, just a different terminology. So this one was written by Willie McAllister. So credits to this person. Okay, this one came from him. So let's now move on to the diagram, okay, or the default circuit diagram of a delta connection. So the reason why we are calling this one delta, okay, because as you guys can see, if you're going to invert this one, it is now similar with this kind of circuit. Let's just say that it's an inverted delta. But for y, it's very obvious, wherein we have a y circuit diagram in here. Okay, that's why it's called delta to y, okay, transformation. So again, from here you can convert this one into something like this, or vice versa. You can convert this y into a delta circuit diagram. Okay. Well, anyway, so just a fact, okay, that really matters when it comes to delta to y. So a delta, it composed of three nodes, so 1, 2, and 3, and then y is composed of four nodes, so 1, 2, 3, and then 4. Okay, so again, you can transform this one, okay, this delta into pi, okay, configuration. So those two are just the same. Okay, it's just that from 3 nodes it will become 4 nodes. Okay, and then the same with y. Okay, you can actually transform this one into t. So those two are just the same, but from 4 nodes it will become 1, 2, 3, 4, and then 5 nodes. So it's just that there is an additional one if you're going to use pi and then t configuration. Okay, but mostly, of course, we are going to use this kind of circuit. Itong nasa unahan. Kasi ang topic lang naman natin is Delta-Wye resistor networks. Well, you can also use this one. However, this one, you cannot easily solve this one using Ohm's law. So if you're thinking that they are in series, no, okay, because we have a connection in here. So again, if it has a node on this part, wherein meaning there is a another component in here or another component above that, so you cannot easily add them. So the same with this part right here. Okay, so we have a node, so they are not in series connection. So at the end of the day, we're going to transform this pi configuration into a delta configuration. Okay, itong nasa taas na ito. Okay, it's just that parang guguluhin kasi kayo. Initially, bibigyan kayo ng pi configuration. Okay, it's not directly on the delta configuration kasi kapag nasa delta na siya, then napakabilis na lang. One step na lang and then you'll be able to convert that one into Y configuration. So initially, they will always give us this pi t configuration. And then your goal is to transform that one into a delta configuration. Okay? Well, anyway, so let's move on to the next one. So when it comes to label, we have this default labeling. Okay, so do not change this one to avoid confusion when it comes to your solution. So RA is on the bottom right, and then RB is on the bottom left, and then RC is on the top. Okay, and then when it comes to X, Y, and Z, so wherever is your IE, RA, so ang i-memorize nyo na lang, isa lang. Okay, kung hindi lang to open notes, ang technique na masasuggest ko, kasi syempre, online distance learning, it's open notes, so wala kayong pinaproblema. Well, anyway, the only thing that you guys need to memorize is this RA, RB, and RC right here. Okay, so once you have memorized those, then you can now easily point where is your X is. So RA, ito na lang, sulat ko muna. RA is equal to X. RB is equal to Y, and then RC is equal to Z. So it seems logical, right? So ABC is equal to X, Y, Z. Okay, correspondingly. So dito, ang para magiging pattern nyo, so wherever is your RA pointing, that is your X. Wherever is your IB pointing, that is your Y. Wherever is your RC pointing, that is your Z. Okay, so as a result, para magiging ganito siya. So we have a node right here. So additional node for Y configuration, right? So this will form a Y configuration. So parang ganun. Okay, RC going to Z, RA going to X, and then RB going to Y. Okay, so are we clear with that one?
Yes, sir.
Okay, one more thing. Of course, after transforming this one, it will give you a specific value on this one. So X is equal to, sulat ko na lang ulit dito. X is equal to R1, okay, and then Y is equal to R2, and then Z is equal to R3. Okay, so from here, meron pa ba yun? Okay, meron pa. From here, so magiging ganito siya. Okay, and then the extra node in here. Okay, so as you guys can see, this is the delta connection, the RA, RB, RC, and then the middle one is your Y connection. So parang yun na yung pinaka-pattern nyo on how to transform this delta into Y configuration. So wherever is our X, that is our R1. Okay, wherever is our Y, that is our R2. Wherever is our RC, okay, that is our R3. Okay. Well, anyway, that is the only tip or the pattern that I can give to you guys, and then the rest are now up to you. Okay. So, kanya-kanyang parang style kasi. Okay, that's my style. Iba din yung sa YouTube. Okay, iba kasi yung parang natutunan ko sa instructor ko dati. So, nakalimutan ko na kung anong pangalan nun. Pero, yeah, ito yung tinuro niya sa akin. Okay, or sa amin pala. Okay, sa YouTube iba din. So, nag-stick na lang ako kung sa ano yung naalala ko. So, ito rin yung tinuturo ko sa inyo. So, you can do the other pattern if you want. So, as long as we'll arrive with the same result. Okay. Well, anyway, so for us to be able to solve this R1, we have this formula right here. So, time check, 6 minutes left. So, okay, kasya pa yan. Okay, so in here, when it comes to transforming a delta to y, okay, so one thing that you guys will notice is our denominator is the same. Okay, that is from delta to y. So when it comes to equations or formulas, pwede nyong isulat ulit to. So from delta y, okay, so we have a common denominator. Parang pangit yung common, same denominator. So, vice versa. Susulat ko na rin ngayon. From y to delta, we have the same numerator. So, napakadali lang siyang tandaan. Okay, however, wag nyo lang pagpapalitin. Okay? Kasi pag pinagpalitan nyo itong dalawang to, of course, mali na yung sagot nyo. Anyway, so when it comes to y to delta, we have same numerator. So, you guys will see later on the formula for the y to delta. But for now, let's have this formula right here from delta to y. So when it comes to R1, so balik tayo sa drawing natin. When it comes to R1, we are solving this R1 right here, right? So as you guys can see, the side-by-side resistor is RB and RC. So yun lang yung kailangan natin. Oops. Those are the only things that we need for us to be able to solve this R1 right here. So RB times RC divided by RA plus RB plus RC. So when it comes to denominator, just get the summation of those resistance. So in here, for us to be able to get the R1, it's RB, okay, and RC. For if you want to get the R2, so the R2 is on this right side, upper right, and then the resistors next to it is the RC and RA. So just multiply those two with each other. So RA times RC, okay, divided by the summation of the resistance. So the same with the R3 right here. So it's RB times RA or RA times RB. Okay. So were you guys able to get that one? The pattern on how to solve the R1, R2, and R3?
Yes, sir.
Yes, sir.
Okay, so since this is open notes, so pwede nyo naman itong balikan kahit anong oras nyo kailangan. Okay, so yung sinasabi ko lang is parang para hindi nyo na, let's say, dayain yung sarili nyo. Yun na lang yung way para i-memorize nyo. Kung gusto nyo talaga matuto, just memorize this one. Okay, or familiarize, and then eventually you'll be able to recall the correct formula of this one. Okay. So yeah, that's it for the delta to y. So let's now move on to y to delta. So I mentioned a while ago that we have same numerator for y to delta. So there you go. So when it comes to y to delta, we have R1 times R2 plus R2 times R3 plus R3 times R1. So lahat sila pare-parehas na. Okay? And then, of course, RA is always equal to R1. Okay? So, R1 will be pointing out on this one. So, ito yung makukuha yung value. Okay? And then the same with RB. Okay? RB, where is our RB? RB is equal with our R2 right here. So, balik lang kayo dito sa diagram na to para malaman nyo kung saan ba yung R1 natin, and then saan siya equal. So R1 is equal to RA, okay, which is this one. And then RB is equal to R2. And then RC is equal to R3. So yun yung parang magkaka-partner lagi. So that is why this setup or yung parang standard uh, labeling natin sa delta to y is very important. Okay, so we have the x right here, y, and then z. Okay, we have the RA right here, RB, and RC. So, kapag pinagpalit-palit nyo tong mga to, okay, you won't be able to apply this kind of formula anymore. Okay, mag-iiba na rin yung sagot nyo. If you want to stick with this kind of formula, or 1 times R2, etc., etc., okay, you have to stick with the labeling also. Okay? So, there is no way na kapag pinagpalit nyo tong Z at saka X, tama pa rin yung sagot nyo. So, dapat alam nyo yung tamang positioning. Okay, if you want to use this kind of formula. Pero kung pinagpalit nyo, as long as you stick with the concept, you know, R3 times R2, kung sakaling R1 to, then R3 times R1. Ganun lang naman yung mangyayari. And then you will still arrive with the same result. Okay? So, yeah, just an advice. If you want to memorize this one and then use this one all throughout when it comes to delta to y and then y to delta. Well, anyway, so are we clear so far when it comes to y to delta?
Yes, sir.
Yes, sir.
Yes, sir. Nag-gets ko.
Okay, very good. All right, so time check again. We now only have 50 seconds, I guess. So we'll just continue the rest on the party. So goodbye for now, and then see you guys later.
Sige po, sir.